Hello, Year 9. Welcome to online lesson week 4. Today we'll be starting on a new topic which is on crude oil, and our first lesson is on hydrocarbon. Right, to start off today's lesson, there are few keywords that I want you to write down in your exercise book. The keywords are hydrocarbon, bonding, alkane and alkene. These are the keywords that we will be using a lot in this lesson, and I will explain the meaning for each one of them as we progress through the lesson. I have listed down 6 questions that I want you to answer in your exercise book as well. So these are the questions based on the topics that you have covered in year 8. So it's going to be a small revision session for us to recap on these topics as we go along. So pause the video now and write down the keywords and try to work out the answers for all these questions. Okay, now all the answers for the quick quiz are listed on this slide over here. So for question number 1, what is the atomic number of an atom? This is the number of protons in an atom. So the atomic number or the proton number can be represented by the symbol Z. So if you look at the first diagram, X represents the chemical symbol for the element. Z represents the atomic number, which is the same with the number of protons. And A represents the mass number. So mass number is equivalent to Z plus N. So again, Z is the number of protons and N is the number of neutrons. So we can look at carbon atom 12 as an example. So the symbol for carbon atom is capital C, and the number 12 represents the mass number, and number 6 represents the number of protons. Remember, atoms are neutral, so they should have equal number of protons and equal number of electrons to cancel out the oppositely charged particles. So that means the number of protons is also same with the number of electrons. So the 6 represents the atomic number, which is the same with the number of protons and also the number of electrons. Right, let's move on to question number 2. Name KOH. K represents potassium and OH represents hydroxide. So this is a compound, and the name of this compound is potassium hydroxide. So question number 3. What is the mass number of an atom? The mass number of an atom is the number of protons plus with the number of neutrons in an atom. So going back to the first diagram, like I said, A represents the mass number, which is the number of protons plus with the number of neutrons. So when you draw the diagram of an atomic structure, you will find the number of neutrons and the number of protons represents the nucleus, which is right in the center of an atom. And then you have the electron, which is a negatively charged subatomic particle, will orbit the nucleus. Question number 4. What is the name for a substance made of billions of oppositely charged ions joined together? So this type of structure or substance is called giant ionic lattice. That means giant ionic structure, like you can see on the diagram next to it. So you have the giant ionic structure, and this giant ionic structure is made of from oppositely charged particles. So you have the positive charged particles and you have the negatively charged particles. Both these oppositely charged particles are held by a strong electrostatic force to keep the shape or the structure of a giant ionic lattice. Okay, so sodium chloride is an example of a giant ionic lattice or structure. Right, so question number 5. Explain why ionic compounds can conduct electricity in any solution. So in the solid form, ions in giant ionic lattice or structure are held in the crystal structure, like how shown on the diagram above. And they are not free to move, therefore they cannot conduct electricity. So when the solid started to melt, the ions are free to move. They become good conductors and can conduct electricity easily. Okay, so question number 6. Explain why methane has a low melting point. It is a simple molecular substance with weak forces between the molecules, which are easy to break. Alright, year 9, our new topic today is on crude oil. So we'll be looking at the structure of hydrocarbons, but before we go into hydrocarbons, we are going to look at the definition of crude oil first. So what exactly is crude oil? Crude oil is a finite resource that is found in the Earth's crust. That means it is a non-renewable resource and it will eventually run out one day. So it is formed from the remains of organisms that lived and died millions of years ago. Crude oil in its original form is not very useful. So fractional distillation is used to separate the crude oil into a number of different parts called fractions. If we look at the structure of the crude oil itself, it is a complex mixture of hydrocarbons. That means it's a mixture of hydrogen and carbon atoms joined together in the structure of chain and rings, like how you can see on this PowerPoint. So hydrocarbon itself, they are in a form of a compound. So do you still remember what is the definition of a compound? Can you pause the video and write down the definition of a compound? Right, a compound is a pure substance that contains two or more elements that are chemically joined together. So if you look at hydrocarbons, it got hydrogen atoms and carbon atoms, and these two atoms are chemically joined together to form the compound, which is the hydrocarbon. There are many useful substances made from crude oil, for example, solvents, lubricants, and detergents. So you can even pause the video now and write down 5 different things that you can see around your house that are made from crude oil. Okay, for example, candles, eyeglasses, plastics, shower curtains, water pipes, toothbrushes are all examples of product made from crude oil. Now you can see the importance of crude oil in our daily life. Now we are going to look at how crude oil is formed and what do we want from it. So we drill for crude oil, which is found in the crust of the earth. It takes millions of years to form, and it is formed from the remains of dead sea creatures and plants such as algae and zooplankton. Over time, sediment collects at the bottom of the ocean. As the pressure and heat builds up, these layers are compressed to form oil. So crude oil is a mixture or in its natural state is not very useful. But the different hydrocarbons that make up the mixture called fractions are useful, with every fraction having different application. So that means in its natural state crude oil is not very useful. So we use this fractional distillation to separate the different parts in the crude oil so that every part have different application, which can be useful for our day-to-day life. Crude oil contains hydrocarbons. Hydrocarbons are molecules that contain just hydrogen and carbon atoms. These can vary in size, which also affects their properties. Crude oil is a mixture of hydrocarbons. It contains many different sized hydrocarbons, which can be separated and then used for things such as jet fuel and petrol. Right. This slide over here shows different types of products like plastics, petrol, pharmaceutical products, and cosmetics. All of these types of products are produced from crude oil. Right. Now look at the two images. They both examples of a hydrocarbon. Looking at the pictures, try and work out a possible definition of a hydrocarbon. If you look at the diagram on the left-hand side, that is the molecular structure for methane. The formula for methane is CH4. And the diagram on the right-hand side is the molecular structure for ethene. And the formula for ethene is C2H2. So you need to work out a possible definition. What do these two compounds have in common? So pause the video now and work out the definition. Right, you can see that most of the compounds in crude oil are hydrocarbons. This means that they only contain hydrogen and carbon atoms joined together by covalent bonds. There are different types of hydrocarbon. Right, this is going to be progress check 1. So I want you to answer the following questions in your exercise book. Question number 1, what is crude oil? Question number 2, how do we get it? Question number 3, name 3 fuels that come from crude oil. Question number 4, name 3 uses of crude oil. And the last question is, what is a hydrocarbon. So pause the video now. You don't have to copy down the questions. You can write down the answers straight away. Right. So for question number 1, what is crude oil? Crude oil is a finite resource that is found in the earth crust. Question number 2, how do we get it? We drill crude oil, which is found in the crust of the earth. Question number 3, name 3 fuels that come from crude oil. So that's going to be petrol, diesel, and kerosene. Name 3 uses of crude oil: pharmaceutical products, cosmetics, and fuels. And the last question, what is a hydrocarbon? Hydrocarbons are compounds that contain hydrogen and carbon atoms which are chemically joined together in chains and rings. Right, so by now you should know the definition of hydrocarbon. Hydrocarbon are molecules that contain just hydrogen and carbon atoms only. One of the hydrocarbons found in crude oil is methane. The chemical formula for methane is CH4, which means methane contains one carbon atom and 4 hydrogen atoms. This one carbon atom is covalently bonded to 4 hydrogen atoms. The covalent bonds are the lines that connect carbon atoms with hydrogen atoms. We will look at this on the next slide. After methane, you will have ethane, which has 2 carbon atoms and 6 hydrogen atoms, and then followed by propane, C3H8, that means it has 3 carbon atoms and 8 hydrogen atoms, and finally butane, C4H10, which means it has 4 carbon atoms and 10 hydrogen atoms. Scientists call hydrocarbons like methane, ethane, propane, and butane as alkanes. So alkanes are the most common type of hydrocarbon found in crude oil. Right, on this slide we are going to look at the molecular structures for alkanes. So we are going to start from methane first. So methane contains one carbon atom which is covalently bonded with 4 hydrogen atoms. Ethane, you have 2 carbon atoms which are covalently bond with 6 hydrogen atoms. Propane, you have 3 carbon atoms which are covalently bonded with 8 hydrogen atoms. And butane, you have 4 carbon atoms which are covalently bonded to 10 hydrogen atoms. So these alkanes can be drawn out to show their structures like how it's shown on this slide over here. Right, now we are going to look at the rules on how to name alkanes. Alkanes are named depending on how many carbon atoms are there on their chain. You need to know the first 4: methane, ethane, propane, and butane. Names always end in A and E. And the key features, that means the formula for alkanes, are CnH2n plus 2. So for every carbon atom, number of hydrogen atoms would be double plus 2. Right, your next task is you need to complete the table below using the rules previously stated. So you need to draw the table, write down the number of carbons, write down the prefix for each one of them, name the following hydrocarbon, and write down the formula for each one of them. The first one has already been done for you. Number of carbons, 1, prefix meth, name methane, and the formula is CH4. There is a challenge question which you can also try. What would the formula of hexane be? So pause the video now, draw the table, and complete the tasks. Right, so for number of carbon 2, the prefix is ETH. So the name will be ethane and the formula will be C2H6. Number of carbon 3's prefix will be pro, name is propane, formula will be C3H8. And the last one would be 4, number of carbons 4, prefix BUT, name butane, and the formula will be C4H10. If you want to double check on the formula, you can always go back to the key features of the formula for alkanes. So the key formula for alkane is CnH2n H2N plus 2, like how I've written just above the table. Use that formula to work out the formula for each one of the hydrocarbons. If you didn't get the formula correct, you can always double check. And the challenge question, the formula for hexane would be C6 and H14. Right, on this slide, you need to match up which ones are alkanes. So I have different kinds of formulas for alkanes, and you need to match up with the right name of the alkane. So pause the video now and try to match up the right formula, chemical formula of alkanes with their correct name. Okay, so if you look at the formula C4H10, that represents butane. Remember, the formula for alkanes are CnH2n plus 2. So if you have C4, if the N represents 4, and then for H, for hydrogen atoms, 2 times 4 plus 2, that would be 10. So C4 for carbon atoms and also 10 hydrogen atoms. So that represents butane, and also check the name. So it has to end with A and E. And another type of alkane is CH4, that is methane. That is the formula for methane. So that would be CH4. And then you have C2H6, that represents ethane. And you have the last one, which is C3H8, that represents propane. So for your GCSE, you only need to know the first four. So that would be methane, ethane, propane, and butane. So it is important for you to learn all these formulas and their names as well. So the more you practice on writing this formula and write down the correct name for each formula of alkane, that will be really helpful for you when you go to GCSE. Right, so this is another task that you can try. So on today's lesson, I have lots of tasks for you to try on, so that can improve your understanding of hydrocarbons. So you need to match these keywords to the correct descriptions. So if you want to copy down the whole thing, you can. It's entirely up to you. But if you want to number them, you can also do that. So I'm going to pause the video. Try to match up these keywords to the right descriptions. Right. Once you have done this, you can double check your answer on the following slide. Okay, so the answer for the first one, series of molecules, is homologous chain. Homologous chain is a series of a family of hydrocarbons with similar chemical properties who share the same general formula. For example, alkanes have the same general formula, that means CnH2n plus 2. So all the series of hydrocarbon in alkanes, that would be methane, ethane, propane, and butane, all belongs to the same family group. Okay, that is alkanes. Hydrocarbon means a molecule that contains only hydrogen and carbon atoms only. Alkane is a saturated hydrocarbon. Mixture, more than one substance not chemically joined together. And crude oil is a mixture of lots of different chemical compounds. Okay, this is another extension task that you can try to practice on how to write down the names of alkane family and how to write down the chemical formula for each one of them, and also to practice on how to draw the molecular structure for the following alkane groups. So this can be an extension task, but if you want to practice more, you can do this now. So you just have to copy the table and complete them. So for example, the first one has been done for you. Methane, number of carbon atoms present in methane is 1. The chemical formula will be CH4, and the chemical structure will be as how shown on the table, in the table on this slide. And then you can try to write down the chemical formula for ethane and try to draw the molecular structure for ethane, propane, and butane. Remember, the more you practice drawing the chemical structure and the more you learn about the formula, the better it is. So you will get more understanding on hydrocarbon. Right, on this slide here, I'm going to explain how fractional distillation can be used in crude oil. So I've also attached a YouTube link where you can look up on the demo on fractional distillation. So during the fractional distillation of crude oil, heated crude oil enters a tall fractionating column, which is hot at the bottom and gets cooler towards the top. Vapors from the oil rise through the column and vapors condense when they become cool enough. Liquids are let out of the column at different heights. So small hydrocarbon molecules have weaker intermolecular forces. So they have low boiling points. They do not condense but leave the column has gases. Long hydrocarbon molecules have stronger intermolecular forces, so they have high boiling points. They leave the column as hot liquid bitumen, as how is shown on this diagram. So basically, this diagram summarizes the main fractions from crude oil and their uses and the trends in properties. Note that the gases leave at the top of the column, the liquids condense in the middle, and the solid stays at the bottom. So I would suggest that it's really worth for you to look at the YouTube link so you can get a better understanding how fractional distillation is used to separate crude oil into different fraction. So small molecules basically will have low boiling point. They are very volatile, flows easily and ignites easily, whereas large molecules they will tend to have high boiling point, not very volatile, and does not flow easily, so and also does not ignite easily. So if you can pause the video, draw the diagram and label the diagram correctly, and also if you look at different height of this tall fractionating column, you have all this crude oil has been separated into different parts which are used for different types of application. So if you can draw this in your exercise book, that would be good. Okay, to summarize today's lesson, let's go through some of the key points in today's lesson. So key point number one, crude oil is a mixture of many different compounds. Most of the compounds in crude oil are hydrocarbons. They contain only hydrogen and carbon atoms. Alkanes are saturated hydrocarbons. They contain as many hydrogen atoms as possible in their molecules. And the general formula of alkane is CnH2n plus 2. Right, I hope these key points will help you to summarize our lesson today.